Requesting connection. Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Multispeed Technologies, the Ask Noah show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour to be a part of the program. It is a free call, 1-855-450-NOAH. It's 1-855-450-6624, or send an email to live@asknoahshow.com. My name is Noah Chalai. I am your host, delighted to be here with you as another episode of the Ask Noah show kicks off this evening. Joining me, my co-host, Mr. Steve Ovens. Welcome from blustery South Dakota.
Yeah, bunkering down. I watched the wind take down the rest of my maple tree tonight.
Really?
Yeah.
Was it the kind of take down your maple tree as in like, that saved me a ton of work, thanks Mother Nature, or like, oh gosh, now I have to go clean this up?
Well, it was the one, this maple tree had been struck by lightning and had lost a bit of, like I had to get up there and clean it last month. So it's a little bit of both. We thought it was kind of dying from the lightning tree strike. And so now I don't have to call a professional because now it's been chopped down low enough that I can get in there with my chainsaw.
That's awesome. That's absolutely awesome. And you finished your solar, Steve.
I did. My solar has been live since June 17th. And yeah, it's been nice to be kind of watching all the nerd stats going in and kind of watching how things are populating in Home Assistant. It's kind of interesting. I've been able to pull more out of the API than what they actually expose in the web interface or in the little app. And so that's just, I've kind of started charting each individual solar panel in Grafana to see like when they are most active or how much that they're generating at a given time. And that's been kind of interesting.
So give me a percentage. You buy a solar panel and let's say it's rated for, I'm just making up numbers here, 1 kilowatt. Obviously that's 1 kilowatt at the exact right angle and at peak sun and distance and all the things. And so you might only get 80% or 70% or 50%. So of your panel's total capacity, what are you averaging?
That's a tough one because the panels don't really say as a percentage. So I've got 370 watt panels, but the inverters I have, I believe, are 350 watt inverters. And there's a reason for that because unless you're in optimal range, you're not going to get what's called clipping. So clipping is where your inverter can't keep up with the amount that the solar panel is taking in. Haven't seen any clipping. So I definitely know that I'm not getting 370 watts because each panel is generating about 2 kilowatts a day.
Okay.
But I'm pretty happy. I'm pretty happy with that. We're here in South Dakota. It's based on the irradiance as opposed to the amount of sunlight that you may get, which is a little different. So we are 7th in the country for the amount of irradiance that gets generated throughout the year. So
interesting.
Yeah, we generate a decent amount of solar here.
Well, as your journey with solar continues, I would like to pick your brain at a deeper level because that's something that very much appeals to me from the standpoint of own your own everything. It seems like solar's a great way to go with power. There's a nuclear reactor in the sky. You can just take advantage of it.
Yep. The only thing that blocks you is, and not even the sun, the clouds. The clouds do hinder you, but even on a cloudy day, it produces things. But really the night is the big thing. You have to have enough battery power. If you want to be completely self-sufficient, you have to have enough battery power to last you through the night.
Storage is the key. Well, we'll continue to follow that. I want to dig in with you deeper on a later date. But you ready to get into some feedback?
Absolutely.
All right, let's do it. Starts with Nikki. Nikki writes in and says, "Hi, Noah and Steve. I'm trying to centralize my files in one location, which is my Debian NAS. My primary workstation is my laptop, Fedora 36, and my other is a Raspberry Pi and a Debian 11 VM. I would like the Raspberry Pi and Debian 11 VM to have the same copies of the files that I have on my laptop. I thought of using SyncThing, but in order to get this working, all nodes would have to have enough local storage space, which is simply not possible for me. I was thinking to use SyncThing between my laptop and the NAS, and then from the NAS, I would export a directory that I could NFS mount both the Raspberry Pi and VM. The mounting process is going to be done via AutoFS, which I believe is the standard way for an enterprise environment. Basically, the /home of the Raspberry Pi and VM will live on the NAS. My questions. 1, if my plan of action is correct and doable, or would I get some sort of issues with permissions since the UID and GID I have does not match between the NAS, Fedora, Raspberry Pi, and VM? Secondly, if I have another user who logs into either node, would he or she be able to see the contents of my /home? And thirdly, I have FreeIPA that I use for both LDAP authentication for my services, Nextcloud, Emby, etc. What I'm thinking is to utilize a centralized UID GID, but do I need to join the Raspberry Pi, VM, Fedora, and NAS all to the domain? Thanks, Nikki. So I guess let's break that down, Steve, into a couple of different questions. First of all, let's look at the global picture. Do we agree or disagree that the concept here of, hey, we're going to have all of the storage on a central NAS and then we'll just mount those directories remotely, I assume over NFS, something like, yeah, he says specifically NFS, using AutoFS. That seemed like the go-to strategy here?
It is definitely a viable strategy. It's one that has been used for quite some time. I personally like the systemd mounting option. I've talked about that before. I guess I grew up in Linux with AutoFS, and I don't particularly like it. So it's just my own personal bias. As soon as the systemd mount came along, I was like, yes, this is the thing that I want. Why wasn't this AutoFS?
So tell me a little bit more about the systemd mount. I know we've talked about it a little bit in the past, but how does it work? Somebody wants to set that up. If Nikki's listening to this and saying, okay, well, I'll go with the systemd route, what would he or she do?
So it is just an entry inside of your etc FS tab. So in there, you would put x-systemd.automount, and then you can also set a timeout too, just like you would with AutoFS. So like if it times out after some amount of time, don't mount it. And that's basically it. So you give it the type, so it'd be NFS in this case, it sounds like, and then you'd put that mount option in there, and away you go. And part of what I like about how this works is you can do lots of things with systemd, like say it has to be mounted before all of these other work units happen, or I have just found it works more consistently. So there are times where AutoFS, you'd go to CD into a directory and it like hangs, and it'll eventually connect usually. But it has been my experience that systemd seems to do that better. Now maybe I'm just biased, right? You have confirmation bias where I hated this other thing, so this new thing must be better, and maybe it's some of that. But that's what I like to do for mounting things out of the NAS.
Okay, and we'll include a link to, I believe it was Manjaro's, the documentation that you had sent me for using systemd to auto mount FS tab, and so we'll include that in the show notes. You find those at podcast.asknoahshow.com. So okay, so we're on the right track. So now, is the plan doable? First of all, is the user ID or group ID, is that going to be a problem if they don't match between the three endpoints?
It depends on how you want to handle the permissions. So there are extended permissions inside of Linux, like you can use ACLs so that you can add additional UIDs or group IDs to give it permission. So when you look at file permission on Linux, you'll see, 777 or whatever the numbers are, and they stand for the owner, the group, and then the other or everyone else. But on top of that, your ACLs allow you to add more attributes to the owner or the group, or even other if you really wanted to define that better. So you could go that route. You could just simply attempt to make the UIDs match across the board, so that on your NAS, and well, your NAS doesn't matter at all. It's the one storing the files, not accessing it. But on Fedora, Raspberry Pi, or your VM, you could try and standardize the UIDs. The other thing you can do is you could look at learning how to do UID mapping, and that is definitely an option that has been used in enterprises for quite a while. So it's a little more technical than I want to explain here, but the basic idea is you set up some rules inside of your FS tab or wherever that you're going to do your mounting that just says I'm mapping this UID to this UID, and it kind of masquerades as a different UID. So there's a way to do that there too.
And for the third question, so if they have, or I'm sorry, second question. So somebody walks up to one of these nodes and they log in. I'm going to amend this question just a little bit. So they log in as that user or know enough about the computer that they can do like an NFS show mount and see what's available on the network? Are they going to be able to see the home directory?
If they have the proper UID or GID, or the permissions are not set up to disallow that. Right? So by default, most people shouldn't be able to read your directory, or very least shouldn't be able to execute or write anything into your directory. So it will depend on how you have the permissions set up. It's possible, but it's the same possibility whether you mounted it from NFS or whether you mounted it on, like, whether it's just a different partition on your hard drive. The same rules of protection apply.
So there's nothing inherently less secure about NFS.
No.
And then the third question, so they have FreeIPA set up and they're already using that for LDAP authentication. Thoughts on use, as opposed to maybe compare or contrast the advantages or disadvantages of using FreeIPA to handle the group ID and user ID versus doing a group ID user ID mapping?
I mean, if you've got an existing set of users and UID, GID, the mapping is going to be I don't want to say smoother, is not exactly the right term, but you'll have a brand new UID, GID from any kind of centralized place, because the UIDs start at a higher number, and that's so that they don't conflict with the UIDs that are generated by the system. So users are normally, it depends on your system. Some of them start at 500, some of them start at 1,000 or 1,001. When you're talking about like a centralized database like LDAP or something similar, like even Active Directory, they start at some obscene number specifically so they don't trample the local users.
Okay.
So you'd have to set up the connection. So there's just a little agent that will run on those various devices that will connect back to the FreeIPA server. And then when you log in, you'll have to transfer the files into the place and make sure that the permissions are set properly after that. And then after that point, you should be good. But there's still going to be some manual steps to make sure that you have to reconcile the UID, GID.
Very good. Our second question comes in from Pete. Pete writes in and says, "Hi, Noah and Steve. I'm a huge fan of the show. I listen to the show every week. I'm looking for a comprehensive guide for installing Linux on a Chromebook. My DuckDuckGo foo has not provided what I need. Here are the specs for the laptop that I have. It's an HP 4SH02UA. It's a Chromebook X360 11 with an Intel Celeron N3350. It's a dual core and has, and then he lists a bunch of other things that I don't necessarily think are relevant to installing Linux on it. Thanks in advance for your help and for the podcast." And so, Steve, I think it's actually your wife. You set up a Chromebook and installed Linux on there. What did that process look like?
So it was largely just, it happened that Arch Linux ARM has a section on their wiki for the model that she had, and I just follow the wiki, which was, in this case, was just download the image file and flash it to whatever device that you're using to boot off of, whether it's the MMC or a USB drive or whatever.
So one of the things I've run into, I've done a few different Chromebooks, and one of the things I've run into that seems to be kind of persistent throughout all of them is all of them have, I shouldn't say all of them, most of them that I've come across have some sort of write protection device, either in the way of a screw or in the way of some sort of thing that you need to remove. And the idea there is it locks the Chromebook to only booting the signed software that came with it. And so you can disable the checking of that signed software, but if you don't remove the write protection screw and the battery dies, that flag will be automatically turned back on. And the problem that presents is you've installed an operating system that isn't seen as a signed OS from Chrome. You have not persistently turned off the write protection, so as soon as the battery dies, that flag gets set back. So now the battery is recharged. It comes back online, says, let me check for the signature. Doesn't exist, not booting that operating system. Now you have a real problem. You can't boot into your operating system because that flag is on. You can't boot back into Chrome OS to turn the flag off because Chrome OS isn't there anymore. So your only choice at that point is to blow away the whole install, start over with Chrome OS, shut the flag off, then reboot, then install Chrome OS, then reinstall Linux. If you can remove that write protect screw, and depending on the model you have, that process varies. If you can remove the write protection, you can permanently change that flag to off so that it doesn't check for that signature. In that scenario, then you can install whatever Linux you want, and it'll work just fine. Now, I have linked a couple of things for you in the show notes. One is how to use Linux on your Chromebook, which this tutorial, what is different about this is it essentially uses the native access to Linux within the Chromebook to, I don't know, unlock is the right word, to enable you to install anything you want using apt. And so then you can install a desktop environment or GIMP or whatever. And a second link that we'll have for you is mrchromebox.tech, which is, it's not a comprehensive guide per se, but it has some really useful information on getting this done. The third resource I'm going to throw out there is Keith Myers. He is probably the smartest Chromebook / Chrome OS person I've ever met. Does a ton with installing Linux and apps, and I mean, you name it, he'll show you how to do it on Chrome OS just for the fun of it. And so kmyers.me, you can learn a ton from his blog as well, and he's pretty good about answering questions. So if you bump into him or have very specific questions, he might be a good resource for you. Our third email comes in from Jeremy. Jeremy writes in and says, looking for recommendations for dual booting a distro on an Intel-based Mac. Any suggestions? And so I guess, Steve, I should ask, do you have any experience with dual booting Macs, and has that been a pleasant experience?
I don't really. I was handed a Mac some time ago with it already set up, and I went, this is neat, but I already have my own, and I gave the laptop back. So I don't have a ton of experience with it. I know that people have been using things like Rufus for the boot manager to, or Refind. Mm-hmm. As I did do that for someone one time way back in the day when we were moving from like a spinning Rust drive to a solid state drive. I don't recall the process being very difficult, but that was a long time ago. I have no idea what Macs are like now.
So you kind of hit the nail on the head. Short answer from my perspective has always been, if you want to dual boot, you need a boot manager. Refind is a boot manager that you can install on a Mac, and will let you choose between Mac OS and Linux. So you install Refind, then from Refind, you're able to boot from the USB installer. From the USB installer, you're able to install Linux. Once you've installed Linux, you can use Refind to switch back and forth. Have a link for you in the show notes. Elementary does a particularly good job of supporting this. Link will be found at podcast.asknoahshow.com. Fourth email comes in from Ryan. Ryan says, hi, Noah and Steve, love the show. I have been hearing a lot of different parts of the Linux community talking about RPort recently. I was wondering if you'd be willing to share what it is that has you both you and Altispeed interested. I'm considering transitioning to it myself, but would love some insight from another IT professional. I mean, it being open source and having 2FA by default is awesome, but beyond that, what has you interested in it? Thanks, Ryan. So, really, it comes down to the fact that it's an open source solution. There's nothing functionality that I'm unhappy with Simple Help. It actually works very well and gets all of the things done that I want to get done. If I was to write out a checkmark boxes of features I need, Simple Help pretty much ticks them except for the 2FA thing. RPort does all of that, plus it's web-based, and I think I've said this on a past episode, I'll repeat it here. If I had a choice, I'll use a local app, but if I'm going to have a bunch of web apps anyway, I'd rather them not be Java-based. And so RPort checks that box. The other thing that RPort does that I think is particularly unique and sets itself apart from most other remote management solutions out there, if you have even one client enrolled in RPort on a network, you have a VPN tunnel into that network. It's always been possible, if you have Simple Help installed, it's always been possible to open up that remote point of presence machine and do whatever you were going to do locally on the network anyway. So it's in my estimation, there's no additional security risk or anything like that. It's just streamlining a process of, if I need to access a web interface on something that is local, or I need the SSH into something that is local, why would I want to go through a point of presence box to do that? If you have a network connection anyway, instead of tying up that box and then using it as a jump box, why not just go direct? And our port allows you to do that. So we've not switched over to it yet. It's still very much early days, and I'll definitely keep you apprised as to how the testing goes. But it piques my interest because it's open source and because it does a lot of the things that Simple Help does, but it's open source. So hope that gives you some thoughts. Steve, have you played with RPort at all, and do you have any comparison between it and Rustdesk?
I haven't played with it. I heard about it through you, and that's as far as I got, because the only person that I support remotely has already got Rustdesk installed, and no, I'm not going to overturn that apple cart.
For Steve, it has to not only match features, it has to go above and beyond to make it worth the pain of changing.
Well, I mean, walking somebody through remotely changing the thing that they've been used to for the last year seems like no particular reason to do that.
Yeah, and truthfully, when you're comparing it to Rustdesk, they're both open source anyway. So now you're just looking at management features which you wouldn't use with a single user. So probably not a big thing. Our fifth email comes in from Charlie. Charlie writes in and says, "G'day, everyone. I came across an interesting video on Odyssey. It mentions open source home automation with ESP Home and Atham branded gear from AliExpress, which is preloaded with open source firmware. Do Noah and Steve have any feedback, experience, or thoughts from buying Atham gear from China or AliExpress, considering it got open source firmware? Could it have a backdoor, shady things beyond hardware firmware, or would it be okay? Also, do we trust American or European brands that also have closed source firmware, such as Intel, AMD, Dell, Cisco, etc.? Do we have a double standard when it comes to a nation that we currently reside in?" So, Steve, I'm going to turn this one over to you. Thoughts on ESP Home and AliExpress?
Yeah, so I actually have bought from these guys multiple times in the past. The short answer here is they have definitely been making much better strides now. They had, in the past, they had a custom version of the Tasmota software, which is what they were coming with back then. Like, now you have a little bit of a choice between which software, like firmware, they will ship with. Mm-hmm. I prefer Tasmota anyways. But anyways, the point of that was saying what they had done was, to save costs, they had pared down the amount of storage that was on the device, which was too little for the default Tasmota install, and so they had their own. And so while it was open source, they had stripped out a bunch of stuff, which was fine. But they have since rectified that and are just straight up shipping, at least the last time that I bought from them, straight up shipping Tasmota. And so I've got some light bulbs and some other stuff from them. I've had zero problems whatsoever taking a binary from Tasmota GitHub and just uploading it and just completely wiping and doing it. So I have no qualms with Atham. Mm-hmm. I mean, I didn't do any security testing or anything like that. I suppose there could be some backdoor, but I would think that since what's happening is you're actually replacing the firmware, and I went and got the firmware that I've been using on everything else around here, if I have a problem, it'll probably be in everything that I have.
From the Linux Newswire newsroom, this is the Week in Review with JT.
Condrace has announced their first version that's based on Debian 11 and comes with KDE Plasma. The Slackware-based Portus Linux has released version 5 with 8 different desktop options, and Linux 5.18. Darktable 4.0 has been released. And for the month of June 2022, Steam on Linux market share has increased to 1.18%. GTK5 might drop X11 support, according to one GNOME developer. The Cybersecurity and Infrastructure Security Agency has added a high-severity Linux vulnerability known as PwnKit to its list of bugs exploited in the wild. Refay Systems has launched a new open-source project named Parallels to help keep users safe and applications secure on any Kubernetes environment for free. In hardware news, the KDE Slimbook Gen 4 Linux laptop is now available with an AMD Ryzen 5700U CPU. Star Labs has teased the Starfighter Linux laptop with a 4K display and AMD or Intel processors. And the German-based Linux hardware vendor Tuxedo Computers has announced Tuxedo Pulse 15 Gen 2 Linux Ultrabook, which is out now with a Ryzen 7 5700U and a 4K display. And lastly, the UK government previously committed itself to using more open-source software in its Technology Code of Practice, which was published in 2021. But 38% of government tech workers in a new study say they still don't use any open-source software in their department. On a more positive note, however, the research from the data management company Avon shows 71% of UK government tech workers report the government is now using more open-source software compared with 5 years ago.
We asked you to give us suggestions on what things you want us to dig into. Now, we do that in a couple of different ways. First of all, if you send an email to live@asknoahshow.com, let me know ahead of time of what your thoughts are, what your questions are, what the topics you would like to learn more about. Maybe you don't have something specific. You just have a general area of interest and you say, I would like to explore this further. I would like you and Steve to explore this further and give me somewhat of an idea of how I get my feet wet with this, that, or the other. Well, we've done that, and we've gotten a load of suggestions for you. Most of you are inside of the Geek Lab at geeklab.ninja, and you're making suggestions using the hashtag learning, and that is adding, our bot is going through and scraping all of those suggestions and compiling them into one large topic base that then gives Steve and I an opportunity to understand, hey, this is what people are interested in and this is what people want to dig into. So today we're giving you a basic introduction into containers. And Steve is probably one of the most qualified people to talk about this because this is what Steve does day in and day out, is works with containers and OpenShift specifically. So why containers? The short version is when we write code and we test code, and we have all of these dependencies that are required for the code to execute, we want to include all of this and have this replicated on any environment. And a few years ago, back in about 2010, somebody had the bright idea to say, you know, we've already solved this problem with shipping containers. Sometimes you're shipping bars of soap, other times you're shipping cars, other times you're shipping computers, and at the end of the day, we package them all into standard shipping containers. Those get set onto a boat, the boat goes across, we can load those same shipping containers onto trucks, deliver them to all of the areas. Why couldn't we do that with software? And so in the summer of 2010, they started the process of creating Linux containers. It was later released as FOSS in in March of 2013. So, Steve, I want to dig into the specifics of containers and the technology behind containers. I want to start with LXC because this is what originally Docker was based off of. Tell me what LXC is and why is that really closer to a VM than a container?
So LXC, being Linux containers, is meant to be what's called system container. So that means that it emulates pretty much everything in the stack except for the kernel. That means that you can run systemd or any init system with SSH and all of the rest of the things that you're used to on a host, but inside of a partitioned part of your system. And largely it sees very good performance because it's still touching the metal as a bare metal host, but it allows you to have a lot more density because you can get a lot more of these things in, and you're also sharing the same kernel, so there's some pluses and minuses to that. So the system container has everything that a normal system might have with some caveats, whereas a container that we think of these days inside of Kubernetes or OpenShift or Docker or whatever, those are application level containers. These things have just enough to run, generally speaking, they're supposed to only run a single process. And that process normally is some sort of microservice so that it does only a chunk of thing and then it talks to something else and passes off the data to another thing. And it's highly efficient because you can stack a bunch of things together that will work in coordination. So one of the examples I give is if you've got you're trying to serve an entire web stack. So you've got a database and some middleware and you've got a web front end. In the old days, you'd have a database server and then you'd have your middleware and then you've got a bunch of VMs. Maybe you bundled them together, maybe you didn't. And what you do with a container is the database would be separate, the middleware is separate, and the front end is something that you can stack 15 or 20 Nginx or Apaches up in front of that in a very dense manner. Every time that you spin up a VM or even an LXC, there is resource overhead for all of these additional processes on that are making up kind of that system level layer. When you're using an application layer container, it doesn't need to have anything more than what's required to start Apache or Nginx or whatever. So you go from maybe something that's, a gig worth of memory in a VM to something that's 100 megs or whatever you're allocating to your web serving process, which means that you can get say 10x times the number of density on a host.
So LXC is containing the entire file system, whereas a regular container. So they later, 1 year later, with Docker version .9, they swapped it for libcontainer. So this is that very specific, just sharing the kernel thing that you're talking about. Yes.
Yeah.
So I'm sorry. Go ahead.
Nope. Go ahead.
So we start with a container host. This is the device that's actually running all of the containers on it. Now, why do we call it a container, Steve? How is that isolating the processes on the host? How does that work?
So I'll give you the short version because I've written 11 articles to tell you how these things are all built together. But the short version of this is there are Linux namespaces and there's something called C groups, and they work in conjunction to limit things at a kernel level from each other. So file systems will, for example, the mount namespace allows you to limit who can see what on the file system at a kernel level. And it makes it very hard, not impossible, but very hard for you to kind of breach those barriers. And so all of these processes work together to what we say contain or sandbox an application process.
Okay. So we no longer really have mounted file systems. We no longer have user IDs, networks, trees. All of these things, if they exist, are either in the container or have to be explicitly passed through to the container. Do I understand that right?
Well, you do still have UIDs and GIDs because the host can, as root, you can still get into the container. That's the thing that you need to remember. These are still all just processes running on a box. So to be very clear, they're just processes running on a box. It's just a way to keep them away from each other. So a container may use UID 10,006. That UID might not exist on the host, but that doesn't mean that the root user couldn't go into the user namespace and impersonate that UID. So the UID exists inside of its own namespace, completely separate from everything else, but with sufficient privileges. So you think about it this way. If you have the privileges to be able to create that, you probably have the privileges to be able to impersonate it.
Okay, that makes sense. And these containers are all ephemeral, which means that containers are short-lived. So they're really not designed to, you don't build a container and install something into it and then it runs forever, right? They're the Tupperware. You spin them up, use them for a little bit, and then you throw them away. Do I understand that correctly?
Depends on the architecture that you're going for. So if you're going for the traditional microservice architecture, so a microservice is where you take an application and you look at all of the functions that it does, and instead of having one big application, you now split it into 10 different little tiny applications that just do one section.
Okay.
So you have something that just receives the URL, and one thing that just displays pictures, and one thing that renders text. And instead of having those all together, they're split up into tiny little containers called microservices. And those are the things that they spin up and then they die. They turn up, they do their job, they report the result, and then they go away. And that's exactly what happens in a Google search, for example. Every time you search something in Google, a container spins up just to handle your search, and then it goes away. No
kidding. And do you have any more insight as to what Google is using kind of behind the scenes to do that, or?
I'm not exactly sure. Google does a lot of their own stuff, and I know that they spin up on the order of a billion containers a day. Like, it is just insane. Well, you think about how many searches that they're handling, and how every search is its own container that just lives long enough to do the search and then it dies. So I know that at one point they were using a modified version of Gentoo and stuff like that. So that whatever they're using now on the back end, I'm not really sure.
That's fascinating. So we can break this apart. So far, we've mostly been talking about the runtime. That is the place where these images are actually running. But the Docker containers in general. I'm going to train myself to not say Docker. We're going to talk about why in a second. But the container we've talked up until this point really talked about it at runtime. But there's also image files and Docker files. And so a Docker file is really just a way to compose an image, and an image is really just kind of like a binary snapshot of a container that you can then transfer to and from. Now, why is that useful, Steve, or how do we use that in a meaningful way?
So let's start with what an image is like. An image is very much like an ISO. It is, once it's built, the image is basically immutable. You can deconstruct it and rebuild it just like you can an ISO, but you can't just write to an ISO just like you can't write to an image. So I wanted to just draw that distinction so that people have an idea, some sort of idea of what's happening there.
Yeah.
As for the container file, so you'll be able to search Dockerfile and pull up all the information you need. But the industry is moving towards calling it container file because Docker is no longer the primary player in the enterprise. Now, smaller businesses will probably still be using some Docker, but on the whole, there is something else that's taking its place, whether it's CRI-O or Podman or things that are just abstracted from people because they're using Kubernetes or OpenShift. Like the people using these orchestrations, they don't tend to care what it is that's actually running in the back end because they're talking to the orchestrator who deals with whatever. So container file is just it's almost like an INI style declaration where you've got from and then you list whatever your base that you're going to be. So from CentOS, from Ubuntu, from whatever. That's just saying this is the base that I'm going to build this container out of. And then you have a bunch of run commands or whatever, however you're going to construct your container. And then once you have this file, you can send that file to anybody who can open it up just like a bash script and see what's going to happen. And you can point your container build at that file and it will interpret that and kick you out an image. So you don't have to share a Docker image. You can literally just share this file and anybody who's got the runtime can do a Docker build or a Podman build or whatever CRI-O build, whatever tool you're using, and it will ingest that file and kick you out an image as long as you have access to the same source stuff.
Now, this is interesting, right? Because it gives us a level of granularity and modularity. If we have this parent-child relationship where, let's say we start from, the scratch where you have maybe just BusyBox, and then on top of that, you have another container that has SSHD and Perl, and maybe on top of that, you have your actual app. This allows us then to swap any individual component out. So, for example, BusyBox has a vulnerability and it needs to be patched. Once we've patched that BusyBox vulnerability and, of course, tested it with everything upstream on the tree, now we can be fairly certain that any vulnerability that was previously exploitable in our system has now been patched all the way up the line because we no longer have individual copies of all of this stuff running multiple times. We can then share these containers from one to another. And we can also pull from a specific branch. So we can say, starting from, again, going back to our example, if we had, BusyBox, SSHD, Perl, and then app, maybe we have a different app, but we could pull everything from SSHD and Perl all the way down. So it'll include BusyBox and Scratch. And now we can have a second copy where we have maybe a second app or something like that. Or we have those same containers and they're simply just shared with that second app. So that provides us with a number of flexibility and scalability. Talk a little bit about the Open Container Initiative, OCI. So this is fundamentally what makes what you were just talking about possible, right? That there's an agreed upon standard that we build containers and why you've pleasantly been providing some pressure to me to get Docker out of my head and just container. What is OCI and why is it relevant?
Well, I mean, you basically just described it, so I'm not going to go over that again. It's an open standard. And the reason why we're trying to allow people to recognize that it's not a Docker thing, it's not a Podman thing, it's not a Red Hat thing, it's not a Canonical thing. This is the open standard. And if people are building tools to read the open standard, like a CRI-O or a Podman or a Docker or a Rancher, all of those tools are built being OCI compliant, which means that the files that you use to construct the images from are portable across, and it doesn't matter what your runtime is.
So I want to talk a little bit about container registries, because this is where you differ from a lot of the rest of the container running world. A lot of people will just pull or push from a container registry, a collection of containers that you can pull images from or push up. And the interesting thing there is, if you're doing that, if you already have one container and there's an update to it, it's only going to pull the diff. Likewise, if you contribute a change back, it's only going to push the diff. So there's a tremendous amount of scalability in registries, but you often won't use a registry, Steve. Talk a little bit about why that is.
So I'll use a local registry, but that's different. Like, I'm not going to be using a public one. I do in some cases. There are some vendors that produce software that is only available from their repo, or it is just a beast to try and figure out how to get it to install in a container yourself. Mm-hmm. But for the most part, I had very poor internet before I moved to South Dakota relative to most of North America. And so that meant that with the lab that I had and the amount of stuff that I have to do for work, if I'm pulling 500 megs a gig for the image, I'm waiting. Whereas, so I actually, before I moved to South Dakota, I ran a mirror for Pacman, for CentOS, for Ubuntu, and I think that was it, because those are the top three big guys that I run. Mm-hmm. And RHEL, but RHEL shares the same base. Anyways, and all because I had 50, 60 VMs or things that I needed to update, and my internet pipe just would not support it. Like, if I left it updating, I would wait 2 days just for all of the things to cycle through, because it's a lot, right? Like, you think about having a 2 or 3 gig update, which is not huge, and then doing that 50 or 60 times, and then needing to throttle that connection during certain times so Netflix worked for the kids and I could make my online phone calls and all of those sorts of things. Like, the realities of having a fairly slow internet connection really can be painful. So I build most of the things locally, and then there's an aspect of training to it, because I can't just pull the file. I need to actually figure out, how did this work and how do I install it? And if I was trying to be particularly masochistic, I would try and do things like use the software collections from Red Hat, which is basically updated binaries for Python and PHP and all the rest of that sort of stuff. Mm-hmm. That in and of itself, it's not bad. But the way that they are doing the way we are doing our software collections is almost like a chroot system, mm-hmm. which, if you try and translate that into a container, can be really, really difficult, because they change the root for all of the application binaries to some obscure, like, ops blah blah. Like, it's a really deep path, and then trying to figure out how to make all of those things talk to each other in a container when you can't just do a chroot, because that doesn't really work in a container.
Because you can't escape the namespace.
Yeah, exactly. So there was a big learning curve for, like, how do I use software collections? And I wouldn't even say that I'd be able to teach anybody. I stumbled my way through and called it good.
Okay. But you understand, but there's an important thing that I want to drill in on here, because I think it's very much overlooked by our society, particularly the next generation of technologists. You want to understand what's happening under the hood, as opposed to just, thanks for the magic recipe. I'm glad that I can make cookies now because the recipe showed up and I put it into the magic box and somehow cookies came out.
Yeah, I mean, I guess that's the weird part of my personality, is that when I get interested in something, I want to pull it apart. Not necessarily in an engineering way, but I kind of have this, it's a little bit of behind the curtain, but I kind of have this fear that if someone ever asked me how, like, if I understand what it is, mm-hmm. to be in a situation where I say, no, I don't know, but I'm using it anyways, that seems like an embarrassment to me, right? I have yet to meet anybody like me that actually cares enough to, like, quiz me on this stuff, but that kind of social fear still drives me. Like, I should know how to say something about this is reasonably intelligent.
I like it, and I appreciate you taking the time to share this with us, because this is absolutely fascinating. Like I said, it's different from most of the container people that you run into. So let's talk a little bit about I'm going to call it a container client. So the idea here is that you have a way to manage the host, you have a way to manage port forwarding, plugins, overlay networking, these kinds of things, and there are different container clients. And so Docker was kind of this monolithic, powerful, independent tool, had all of the benefits, whiz bang whistles, all of the things. Now the industry is starting to move away from that and moving towards more generic tools. And one of the really popular ones is a collection of tools, Podman, Scopio, and Buildah. So tell me a little bit about what Podman, Scopio, and Buildah are and how they relate to the Docker monolithic beast.
So we'll start by talking a little bit about Docker. So I'm sure that most people are aware Docker requires a daemon. And with some small exceptions, it used to always require to be run as root because it's a daemon that had to do lots and lots of things. And more recently, they've been making ways to have rootless Docker, but you still have to have a daemon. And well, let me phrase it this way. The last time I looked, you still had to have a daemon. And so Podman came along. They looked at what Docker had. And it's not really a fault of Docker. This is what happens when you are the first one out the gate. You get out the gate and then you get feedback and maybe you have to bolt it on because of the way you architected wasn't intending to have whatever functionality your audience is asking for. And so then the second man up has the advantage of seeing where your deficiencies are, being able to strip down itself, and instead of building a rocket, we'll build a SpaceX that eventually will be able to land itself. And that's kind of what's happened with the Podman and Buildah and Scopio and Run-C and a few of those other things, is they looked at what Docker had evolved into, kind of pulled it apart, and then said, okay, well, we don't need a daemon to actually create containers. We never have, right? You can today create a container by hand with just running a bunch of commands on the shell, like in your shell. So you never needed a daemon. So Podman came out and was like, okay, well, we're going to be rootless. We're not going to have a daemon. We're going to follow these OCI standards and so on. And that was its goal. That meant that some of the stuff like building the containers, you can use Podman to build a container, but there's also Buildah, which is the dedicated open source tool to do container building. And then there's Scopio, which helps you to do registry kind of manipulation. So for example, if you wanted to transfer an image from one registry to another, you can use Scopio and it will kind of handle making sure that you're getting copies in the right place and stuff like that. So ultimately, all like Podman, Scopio, Buildah, Run-C, and stuff like that, they just looked at what Docker has done in the past and decided, you know what, we can probably improve on that. They have a lot of legacy baggage. We don't. So here's what our proposal is. Okay. That's basically it.
So point blank, there's somebody listening to this episode and they're listening to this and going, yep, okay, you guys have sold me. I want to get into containers. I'm going to go home and play with this. For the record, you're saying probably if you're looking to get into industry or playing with this stuff, nobody is shooting themselves in the foot by saying, I'm not going to go with Docker proper. I'm going to go with Podman, Buildah, Scopio, Run-C, and I'm going to do these things with these individual tools. You're not giving anything up. You're still working within the OCI compliance standard. You're still able to do all of the things that somebody would do with containers, and in some cases more, and we'll get to that in a second with Kubernetes. But am I understanding that right?
Yeah, at this point, there will be some organizations out there that want Docker-specific knowledge, but we more care about if people understand the fundamentals of containers and how they work, because of the OCI compliance, you should be able to easily pick up other tools.
And in theory, you should be able to go back, right? If you start with Podman, Buildah, and Scopio, in theory, you get your next job and they do use Docker proper, you should be able to just go back, right?
Yeah, I mean, one of the things that I did was I just aliased Podman to Docker, because you're like, after 5 or 6 years of working with this, your hand just types Docker, even though I don't have it on there. So Podman and Docker are, I don't want to say drop-in replacement for each other, but they're really close. Like if you learn Podman, you're going to know 90% of Docker.
We're never going to have time to get to container orchestration, so that will have to be another episode. But speaking briefly about Kubernetes and Kubernetes pods, talk a little bit about why Podman is advantageous here and maybe has a leg up over things like Docker.
So a pod there's two things that are here. Podman is a tool. A pod is a terminology which represents one or more containers that work together to achieve a thing. The reason why it's called a pod is because it represents a work unit, and anything in that work unit can talk to itself over localhost. So with the idea that every container should really only have one process running, because when that process dies, that's how orchestration knows that it should restart the container. So if everything has one process, but you need some extra help. So one of the most common things to do is to have two containers in a pod, one that does the work and one that has a VPN connection. The work gets done, it gets passes via localhost to the other container in the same pod, and that guy handles how to do the VPN connection and all the network traffic and all that sort of stuff. So Podman is actually meant to be able to take that idea of having multiple containers working together in orchestration and packaging that together. So that was really where its focus was.
And does that set somebody up more efficiently to scale into something like Kubernetes down the road?
Yeah, I would say that it definitely will help you in Kubernetes understanding what's happening when you have more than one container in a pod, just because of the way that it's set up.
How about Podman's integration with Systemd? How does that work, and is that a benefit?
Well, I mean, if you like Systemd, I suppose it is. If you hate it, then no, it's not. Podman can work with Systemd. So you can use Systemd for, it has its own way to spin up containers as well. I guess I would just leave that to the audience to go and hunt that down if that was something they're really interested in. Honestly, that's more of a dev thing than anything that I've actually seen out in the field.
And I guess we'll wrap here. So if somebody is out there and again, they're listening to this and thinking to themselves, I want to get into containers, or I want to get into, really, if you're getting into IT these days, if you're getting into system administration, you're probably getting into containers that you either want to or not. What does this look like as far as the industry moving forward? Are things like Podman, Skopeo, are they going to be the future? Is there something else around the block that you're seeing or looking at?
So ultimately, just like we saw system administration giving way to some sort of automation like Ansible or Chef or Puppet or whatever, it became more important to learn those tools than the system administration itself. The orchestration bits, whether you're talking about OpenShift or whether you're talking about Rancher or whatever, those are going to be where people are looking for skills. Just remember that IT is cyclical. So we did this thing where we went from bare metal to VMs, and then we wanted as small a VM as possible, and then we thought, no, that's not really good. We're going to try and go back to the monolith, and then we've come to the container and we've shrunk it down, and now we're like, well, we shrunk it too much. Now we need pods because we need more of them. I suspect that you're going to see VMs make a resurgence in the future, at least in some part, because I think because I base that on the idea that OpenShift and Kubernetes both support managing VMs. And I'm saying if we're managing VMs and they've taken the time to develop KubeVirt, then there is going to be a resurgence there, or at least significant demand, and VMs are not going to go away.
Interesting. Well, we'll continue to follow. Steve, I can't thank you enough for taking the time to walk us through that. Absolutely fantastic and fascinating, the stuff that you do. Part 2 will have to be orchestration, because I know that's really kind of your powerhouse, your wheelhouse. The music in our ears means we're out of time. Before we go, I want to let you know of a couple of things. Hey, you can find all of the show notes, all of the articles and references that we used to make the show. They're available to you at podcast.asknoahshow.com. You want the latest? Follow us on Twitter at Ask Noah Show. I'm at Colonel Linux. He's at Linux Ovens. We're back next Tuesday at 6 p.m. Central. We record the show live at 6 p.m. Central. AskNoahShow.com. Have a good week.